Okay, and welcome back to Geeking with Jody. I'm Jody and I'm solving a CTF challenge. It's rated medium, but only 6 solves in the qualification of the HackerLab.Africa. I'm playing with my team, although if we qualify, which we just had a great place because we just solved this, so this is one of the least solved questions, although the next one opened and we have to go for this, but I'm showing you this one. What I was saying, 7, someone else solved it. A conversation between 2 terrorist groups has been intercepted. It is possible that very sensitive data was transmitted during the communication. Flag is CTF underscore something, and you have one file which is capture PCAP. As soon as you are speaking about PCAP, it's in my expertise. When you want to work with PCAP files, the best thing is download them first. Then open them and check them in the wireshark. Wireshark can show you the PCAP files. PCAP files are interception of the network. So what we have here, human eye is very good in pattern recognition. As you can see, I'm scrolling fast. I'm watching this. This is going kind of recognizable, not very slow, not very fast. So I can browse all the packets by my naked eye. Here I have something else. One ARP package. Okay, packet. Again, I'm browsing, so mostly DNS. As you can see, one DHCP. These looks like normal behaviors of a computer which is working. This shouldn't be part of the questions. These DNSs are part of the questions. SSDP, and I'm going faster, and all of these are DNS. What is interesting is these DNS queries are a little bit strange. They are querying this. They are asking from a DNS if you know about this IP, because type is A. I'm asking to see what is the IP address of this subdomain on HackerLab.Africa. Okay, so it gets back the answer, no such name. This is invalid. Okay, next question. Who has this? No one. Who has this? No one. Anyone who plays CTF enough will know that this looks like a hex string. First idea is saving all of these in one file and looking at that file and see what we have. Furthermore, 89, 50, 4E, 47. Does it look familiar? It's PNG. This is the magic number of PNG. If you know hex, you don't memorize it, although when we were younger, we used to memorize and be proud that I know hex. But this is P, this is N, this is G, and this is 89. So self X, 0X, OX, 89, P, N, G. This is the PNG file format magic number. You may know about the magic numbers. If you search for PNG magic numbers, in programming, magic numbers are codes embedded into files so computers will know what file this is. For example, if we have a list here, let me search for PNG. For example, PNG. It says PNG always starts with 211. This is equivalent of OX89 in hex. This is decimal. Then you have a PNG. Then /R /N space. Then this, not the space, 30 space. Then another new line and all other data. So whenever you have a PNG file, it starts with this combination, same as the data we just saw. These are used by the operating system to understand what this file is. On a Unix-based systems like Linux and Mac, your system will look into this file, will recognize the magic number and will know that this is a PNG. On Linux, on Windows, this is unfortunately done by the extension of the file. So if you change the extension of executable to PNG, Windows will think that this is a photo. On the Unix machines, it will look into the executable and will see what you have. For example, all the Linux executables do have ELF like this, or ELF executables. Not okay. Anyway, compiled executables. Anyway, ELF executables. Anyway, so we have this. One more point. Packet 0 is requesting this address. The next packet is the answer that I don't know about this address. Then we have this, another question. We are querying it. Then we are getting an answer, I don't know about this. So if we want to merge this into one file, we should be sure that we are just saving the questions, not the answers. Otherwise, we will duplicate everything. Back to our programming. Scapy is a great Python module which you can run. It has its own IDLE and it lets you work with the packets. You can create packets, check packets, generate strange packets, unusual packets, and anything. Also, you can read pickup files in it. So I can say read capture pcap. I have to save it somewhere, so I will say my data equals this. If you say D0, it will give you the packet 0, which is exactly this one. If you check for packet 1, it will give you the second one. We have a thunderstorm here, which is very surprising and unusual for this season. So it says on packet 0, on DNS level, I have the query data. In it, I have query name, which equals this. So if I want to find it, what happened? If I want to find it, I have to say D0 packet query data and query name. It will give me this. I can split it using a dot, but since this is a byte data, I have to use byte 2. Why I put the bytes? Okay, so I will split it and I will say I need only the first part. This way I can read this. But how to separate the question from the answer? If you know it, you know it. Otherwise, you can just search. On the DNS layer, I have query QR equals 0. So this is request. Here I have QR equals 1. So I need the packets which are DNS and which QRs are 0. Let's go for this. I can say for packets in data, and I can create a variable here, say my output is binary nothing, bytes nothing, not binary, bytes. And then I can say if this packet has layer DNS and packet, what was it? QR equals 0. So I'm just checking the DNS packets because we had a few non-DNS packets too that would give us will give us an error. So I'm checking if this is a DNS packet and if this is a question, my O should be added to this packets query data, query name. Then we split it by bytes with this one and then chose the first one. Here I created this lovely O. But the problem is that this O is a bytes, but this 89 are the exact characters of 89. I have to convert this to 89, then 50, and to the hex array. First I will create a string from this, so I will take the CHR of this, CHR of this, CHR of this, and then I will convert it to the bytes. I can do it like this. Say O string is, what I want to run is CHR. I want to run on all the O. So I will do a map. This will give me an array. I want to combine that array. So I will say join all the parts of this. And here I've created the O string, which is a normal string from this data. Now I want to convert it back to the bytes. So I can say my O output equals byte array from hex OS. This is Python 3 and very strong in this kind of stuff. Now I have my data as I want it. So here I combined all that data into this, and you can see 89 in hex, then png /r /n and blah blah blah. So I have to write this into the file. I will say f equals open fpng. I want to write into it, and I want to write bytes. F write O from the output. It wrote this much bytes, and then F close. Cool. I will split the window. Then I will go to the temp B. This is where my file is. If I do a file PNG, it will see this as a PNG file. If I open it, I will get this. This is a good CTF from the good group. So this shouldn't be a guessy, just to guess what is this. I can say from somewhere my PNG is broken. You can see from these pixels, these. So my PNG is broken somewhere, just like a bad file, bad downloaded file. Why is that? This took me a while to find out. One of the good commands I tried, which gave me the hint, was binwalk. Binwalk walks on your binary and will tell you if something is combined with something else. If you have a classic virus which attaches itself to another image, binwalk will show you that you have an image in this part, you have a binary in this part, you have a zip file in this one. If I do binwalk on my file, you can see that it sees you have a PNG image in the beginning. Later I can see end of a zip archive. It's looking for all the clues it knows, like magic numbers. And it will see that, okay, you have a zip archive finished somewhere. I cannot see the beginning. And you have a PNG in this. Why is that? Let's go back to our wireshark. You can see that here I have a query for A. When you are doing a DNS query, you can do different kind of queries. A will convert this name to its IP address. You can have AAA, you can have CNAME, you can have different kind of queries. In the beginning, and where the file is okay, we have A response, A response, A response, A response. But if I go down, from somewhere a new group of packets emerge. I have queries for CNAME. For example, here I have a query for A for this address. Then I have a CNAME for this address. Then DNS answered me that no such name A for this address, no such name CNAME for this address. So there are two different streams here. One stream is querying on A, one stream is checking for CNAME, and I'm combining these two in my little script here. which is not good. Here I'm combining them in one file, and here on Beanbag you can see that it guesses one PNG and sees one end of zip archive. Let's try to separate them. In the first packet it's type A. My last packet fortunately is CNAME. This is the answer to the last packet. So I can check them. I will tell data 0, data -1 will be the answer to the last one. This is the query for the last one. Really? I'm out of battery on my keyboard. Let me connect physically. Okay, now I am connected. Okay, so what's the difference? On the DNS layer, I can see that on DNS level, I can see that my Q type under QD is A. On the last packet, I can say under DNS level layer, query data, Q type is CNAME. I have to find the equivalent where I can use in the if. Let's print them. I will say on the first one, data, what was the name? Q type. This is 1. On the last packet, it is 5. So I have to separate this into 2 different files. Let's do it. So this was my loop. I can add another and here and say and packets query data query type equals 1. This is for the first stream. I can do Control R will do a backward search. So I will say O to the string is this. O is this. Open the file. Write the data. Close the file. And here I can say open fpng. And this time we have the clue. On the first video I recorded, I thought this is the answer back. Gave it to my friend who was going to submit this, and he said that I cannot submit this. This has a problem and it doesn't look like a flag. So we continued and I went for the second file. So I will move fpng to f1png and we'll do the same, but this time for the stream with type 5 for the other packets. Same thing, os equals blah blah. Let's create OO, open the file, write the OO and close it. Now I have another file, which is F again. I can check it. File fpng. It says this is a zip archive. This is not a PNG anymore. So let's unzip it. So let's unzip fpng. It says okay, unzip. This is the new file. I can say file flag blah blah. It says okay, I opened it. No, I said file. So this is a zip archive. I can say unzip flag blah blah inflated to this one. Very ugly. This part of the question I believe is ugly. Maybe you need some tricks to do this faster. What I did was I said okay, this is the name of my file. Okay, what I need is, for example, this is my string. Each time I want to remove 2. It seems each time I opened it, it lost 1 word. So what I did was silly print for I in range of 0 to length of A, jump by 2 because each time I want to remove 2, next time I want to remove 4, and blah blah. Print f string unzip what? unzip A and remove the last I numbers. This is what I did. So it created a command for me. Unzip up to U, unzip up to T, and all of them. Let's go up to here. So I create a file here, vim do sh. These are my commands, and I will say sh do sh. Not sure what happened. Let's open it here. I didn't have the last file. So undo this, then do sh again. See, it created a lot of files, but not enough for me. This open to this, to this, to this, to this. So I don't need these. But let's examine and see why I got an error on this file. I say unzip, flag blah blah. It says, okay, I cannot find zip directory. File, flag, it says, oh, this is XZ compressed file. This is dirty trick. So I will do on XZ this file. Unfortunately, XZ insists that you use the XZ extension. So I can say move flag blah blah to XZ. Now I have it as this file. I can say on XZ. Now I have a file opened. Now I have to repeat this all the time. I can say move A to XZ, then on XZ. So I'm renaming it to XZ and then opening it. Opening on XZ automatically removes the extension and open it once. So I have to do this. If I want to show you, I can say like this. See, it's a little bit smaller, so it's opening. Very ugly part. This is fast enough. Here we have a new issue. Now it's not XZ anymore. File AXZ. It's bzip2. So I have to move AXZ to a bz2. And then b unzip to a bz2. It converts to A again. Bear with me, this is very nasty part, I believe, but we will reach funnier place, and this would be quick. So again, each time I will convert this to bz2, then I will do b unzip to a bz2. Okay, now we done lots, and now this is gzip compressed. So I will move a bz2 to a jz, g unzip a jz, move a to a jz, g unzip a jz. Now we have a file with a JZ. Now this is a zip archive, and this is the size, it's small. I will do a move a JZ to a zip and will unzip it. It needs a password. My first guess was this. I tried different combinations of this, it didn't work. But when you are a cracker, or I'm not a cracker, but when you know how people crack, and you reach RockU, you will think of password crackers. One very famous word list, which consists of lots and lots and thousands of passwords, is RockU list. So this suggests that you should break this using a password breaking software. I tried different RAQ, feature lead, whatever, it didn't work. So I moved this to my Kali machine. I would say scp azip to user at okay, now it's moved to my Kali machine. I will create a new terminal. We'll log in there. And we have the file here, a zip. We want to crack this, but how? There are different methods to cracking this. Most of them are just trying passwords on them to see how it works. One of the good tools for this is John the Ripper tools. We have a command which is zip to John. It says zip to John, convert zip's password to format which John understands, John the Ripper, from file azip, and put it in ztxt. If I catch the ztxt, this is the hashed password, and we want to crack it. I can just run John ztxt and ask John the Ripper to crack this. It may take a while. It may not work if they have a complicated long password, but when this is the question and they are pointing you to the RAQ database, this should work. If you want to see more passwords, you can check if you have a Kali on user, share, word lists. There you can find different word lists, common passwords. So we should wait and see how John cracks this. Wait. You can always press enter, or most of the times any other key other than Q and Control C, to see the progress, what it is testing at the moment. And it tried all the password lists from password list of the John, and now it is trying to brute force it. This is not the first time. I found it. So not the first time I'm doing this. I solved it first and then started recording. So I've tried RAQ4U password list, which is here. wc-l user share word list RAQ. It contains 14 million passwords. So it's a huge list, but the password was not there. John the Ripper broke it, and this is the password of the file. So I can do unzip azip 3C0W45. It inflates flag txt, cat flag txt, and it is a QR code. This is a little bit too much. I have to check the QR code. QR code scanner. It did it. And if you can see, hopefully, this is directly the flag. CTF blah 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 blah. I can copy paste it to my computer. Okay, this is it. CTF, welcome hackers. Interesting. I'm glad that this didn't point to another URL, but this is a qualification for a huge and well-known competition, so that's why this has multi-layers, and now we just unlock the next one. Hope you had fun, learned different things. Beanwalk is fun, know about it, install it, play with it, and I would read the PNG documentation, see how PNG works, and find out if PNG has a animation capability. Enjoy.